Hey everybody, it's Catlin here looking at your practice problems for this week. We're hitting up Unit 2, Lessons 1 through 4, and starting with Lesson 1 here. We can probably knock out both of these problems in one video. Which of these shapes is not like the others? I think looking at the three, you can tell that A and B are scale copies. Just visually, C is different. But you have to do more than just say that they're different. You have to actually go back and explain what makes them different by representing each, that means every one of them, A, B, and C, with a width and height pair ratio. So like we set up on the table on our problem in class, you're going to think width to height of each of these figures. So the width to height of A, well, the width is 1, 2, 3, 4, 5, to a height of 1, 2, 3, 4 tall. So you go through there and you count for all of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 wide for B. And its height is 1, 2, 3, 4, 5, 6, 7, 8. So 10 to 8 height there. And I've counted this one before. It's also 10 across, but it's only 1, 2, 3, 4, 5, 6 tall. Alright, so we can see why C is different now. A and B are the same because they're equivalent ratios. You can multiply by a common factor and get to the size of B. But you can't do that for C because C has the same width as B and just changed in height. So that means it's been stretched out horizontally, but it's not equal to either of the other two. All right, let's look at problem 2 here real quick. In one version of trail mix, there are 3 cups of peanuts. So we've got a ratio of 3 peanuts is to 2 cups of raisins. In another version of trail mix, all right, we're going to check and see if these are equal to each other. In another version of trail mix, there are 4.5 cups of peanuts. So they've increased the number of peanuts, but they've also increased the amount of raisins to 3. The question is, are these two ratios in the trail mix equal? Well, we got a lot of ways to check equivalency of ratios. One way is to kind of see if there's a multiplier here like we saw up here with times 2. But that's not easy for a lot of us to know that that's times 1.5. You can get that from dividing 3 and 2, but this would be an opportunity for you to use your butterfly method that you learned in elementary school. Multiply the cross products. 2 times 4.5 does equal 9, and 3 times 3 also equivalent to 9. So that right there is enough to tell me that these are equivalent. Explain my reasoning. Are the ratios equivalent? And we could say yes. And then my reasoning, I think, is enough here in my cross multiplication or my shown work. You could also say that the ratios are equivalent, because they have cross products that are equal. You could write that sentence, but you're kind of showing that here with your shown work. But that's problems number 1 and number 2.